Welcome to linear functions and equations. I put functions and equations up there because some books say linear functions, other books say linear equations. It's pretty much the same thing. When solving linear functions and equations, we're going to be graphing them and so forth. We need to first see if they are linear. Linear means when they are graphed, they'll graph a line. They'll graph a straight line, and they'll graph only one straight line. Okay, in order to do that, we need to put it in standard form. Standard form is ax plus by equals c. Now, when in linear form, your a will never be a negative. Also, your a and b will not equal 0. Okay? Your a, your b, and your c are your numbers. Let's take a look at the first example. I have 4 minus 2y equals 6x. There's a checklist in your head you should go through. 1. Do I have a number and the variable x? Yes, I do. Right here. Do I have a number and the variable y? Yes, I do. Do I have a number with no variable? Yes. So now this is linear. Now I need to put it in standard form. I'm going to rewrite my problem. Now here I'm not actually solving numbers. I'm just moving them from one place to another in order to put it in standard form. I already have my y on this side of the equation. I need to move my 4 over to the other side, and then I need to move my 6 over to the other side. 6x, I'm sorry. By doing that, I solve the opposite. The opposite of a positive 4 is a negative 4. This zeroes out according to my property. I'm left with a negative 2y equals 6x minus 4. Now I need to move the 6x over to the other side because according to standard form, it's an x plus y or x minus y. So the opposite of positive 6x is a negative 6x. I always draw my line just to keep things straight. I'm left with a negative 6x, a negative 2y equals, this zeroes out, that's why I draw the 0, minus 4. Okay, what did I say up here? The a cannot be a negative, so the coefficient in front of your x is your a. That cannot be a negative. Well, it is a negative, so I need to change that. In order to change that, I multiply by everything by negative 1. Multiplying everything by negative 1 through the distributive property will change all the signs. So a negative 1 and a negative 6x gives you a positive 6x. Negative 1 and negative times negative 2 is a positive 2. And a negative 1 times a negative 4 equals a positive 4. I now have standard form. Notice in standard form, my 6, my 2, and my 4. And so when the teacher asks you, what is your a, you look at the coefficient in front of the x, and that's your 6. You look at the coefficient in front of the b, and that's 2. And you look at the well, I don't call it a coefficient because it's not in front of a variable, it's just a number. You look at the number 4. Okay? Now I'm going to tell you something. It's not going to make much sense now, but it will later on. Standard form. Numbers aren't writing very well here. Ugh. When talking about standard form, all your numbers are real. Okay? So they're rational and irrational numbers. We're not going to really get into non-real numbers until Algebra 2. Actually, later on in Algebra 1. Okay? In example number 2, I have a y. Now, it doesn't have a number in front of it, but that's because it technically does have a number in front of it. The number's 1. 1 likes to hide. It does not like to be shown. I'm sure you know people that don't like to have their picture taken, like myself, and that's what 1 is like. Numbers do have personalities, believe it or not. Okay, let's move on. I have a number with no variable, and I have an x with a coefficient of 2 in front of it. Notice in standard form, the x has no exponent on it, where here it has the exponent of 2, or x squared. So right off the bat, we know this is not linear. And you don't have to do anything with it. It's just not linear. The reason it's not linear is because this 2, when we take a look at graphing later on, this 2 will make the line curve. And we're looking for equations that only graph a line. Okay, so let's look at number 3. I have an x. I have a 7, which is a number by itself, and I have a y. No exponents. Technically, they have exponents of 1, but then again, the 1's not shown. So I can put this is linear. It will create a straight line, and now they want us to put it in standard form. I'm going to rewrite my problem of 4x equals 7 plus 2y. I already have my x on this side of the equation, and the 7 is on the right side of the equation. So now I have to move my 2y over to the other side. Okay? In doing that, the opposite of positive 2y is a negative 2y. I'm going to draw my line. On this side of the equation, I have, now what comes first, the x or the y? According to standard form, the x comes first. I have a positive 4x, I have a negative 2y, and I have a 7. This zeroes out, so I don't have to write anything down. I now have it in standard form. The next thing I need to ask myself is the coefficient in front of the x negative? No. So I'm good to go. I don't have to multiply everything by a negative 1. So my a, I need to identify my a. It's the number in front of the x, which is 4. Your b is a number in front of the y, which is a negative 2. And your c is a number all by itself. It gets so lonely on that side. It's a 7. And you're done. Very good. Let's go on to example number 4. Here's a difficult one. It looks difficult because it doesn't have your x, y, and c, or your ax plus by equals c, but this is linear. And let me explain why it's linear. Okay? If you remember, the x has a 1 in front of it. I'm going to rewrite this linear. So it's 1x plus no y equals 12. The 12 is on the right side of the equation. See? I have my y. I don't have a y here, and I indicate that with the number 0. And my x is 1, even though there's no coefficient. You don't see a coefficient in front of it. Technically, there's a 1. Remember, it hides behind the x, so sometimes we have to bring that out. Now, you're probably saying to yourself, wait a second, Mrs. Chapman. You said that it is linear as long as you have your x, your y, and a number. Well, okay, we have that. And your a is not negative. Well, my 1's not negative, so I don't have to multiply everything by negative. But what about this here? A and b can't be 0. Your b is 0. The key is a and b can't be 0. Okay, if I just had something that said equals 12 with nothing in front of it, just equals 12, that is not linear. Your a and b cannot be 0. Okay, in other words, you can't have 0x plus 0y equals 12. You can't do that. So we scratch that out. Okay, so now all I have to do is identify my a, b, and c. Your a is 1. Your b is 0. And your c is 12. So therefore, this is linear. It will create one straight line. Okay, here are some more difficult problems. Let's go ahead and determine whether these are linear. In order to determine whether they are linear or not, we need to put them in standard form, which is your ax plus by equals c. We're going to be moving some around. Notice on number 1, they have the x and the y in the denominator. Let's highlight that for you. They're in the bottom of the fraction, which is called the denominator. I need to get rid of them. When you're trying to get rid of a fraction, you're not really getting rid of it. What you're doing is, in a way, you're eliminating it. You're making it look different. You're moving it around. In order to remove the x from the denominator, I'm going to multiply everything, right for me, thank you, by x minus x times 2, that's not y, over y equals x times 7. Okay, what happens is when I put a 1 under it, I can cross cancel, or that I'm not really canceling it, but it equals 1, and we don't necessarily write the 1, leaving us with 5 minus. Now, when multiplying fractions, because technically this is a fraction, x times 2 is 2x, and 1 times y is y. And 7 times x is 7x. Now I'm going to do the same thing for the y. I'm going to multiply, I want that to be in green. I'm going to multiply everything by y. It's okay as long as I do it to everything. I'm just changing the look of the problem. I now have y times 5 is 5y minus, notice 1 in the numerator, 1 in the denominator. It cancels it out, so I have 2x. So far it's looking good. I have an x and a y equals 7, and 7x times y is 7xy. Notice in your standard form you do not have a x and a y put together. So therefore, anytime you have a variable in the denominator, it is not linear. Okay, now let's do the same thing, but let's see what happens when you have the x and the y in the numerator. I'm going to do the same thing as far as trying to get rid of the 4 and the 3. Now, the easy way to do it is to say 1/4, because technically this is a 1 here. 1/4 x minus, remember this is a 1 here, 1/3 y equals 1. And when we look at it that way, the 1/4 is your coefficient for x, and it's positive. Your 1/3 is the coefficient for the y, and then you have your c, which is all alone. So you have your pen. So you have your a, b, negative 1/3, and your c equals 1. So yes, this is linear. And if I were going to get rid of or move around the 4 and the 3, manipulate it, just like I did with the x and y over here, because I don't want fractions. Some people just hate, the majority of people hate working with fractions. I love it because it seems to be easier. I'm going to do the same thing. I'm going to first multiply everything by the 4, and then I'm going to multiply everything by the 3. And let's go ahead and see what we get. If I multiply everything by the 4 first, equals 4 times 1. My 4's cancel out, giving me x minus 4 times y is 4y. I'm just multiplying the numerators and then multiplying the denominators, equals 4. Okay, good so far. Now I'm going to multiply everything by 3. I have 3 times x minus 3 times 4y divided by 3 equals 4. And 3 times x is 3x minus, my 3's cancel out, giving me 4y. I forgot to multiply this by 3, equals 12. And there you go. It is in standard form. My a is 3, my b is negative 4, and my c is 12. So as you can see, I can showcase this as a equals ax plus by equals c, which is standard form, or the same thing will give me, what I mean by the same thing, even though the equation looks different, it's going to give me the same result on the graph. Okay? Okay, let's go ahead and graph this equation. I have 3x minus 5y equals 0. A lot of teachers will tell you to go ahead, and a lot of books will tell you to do the same thing. To set up a table, you have your x coordinates, your y coordinates. You pick any coordinates you want for x. I like to start with -2, -1, 0, 1, and 2. I always pick them. They're the easiest numbers. They're the smallest numbers. And then plug them in for x and solve. Okay? So let's do it. 3 times -2 minus 5y equals, that's supposed to be a 10, equals 10. Yeah. Who wants to plug in 1, 2, 3, 4, 5 numbers and solve? I don't. Boop, boop, doop, boop, boop, boop. Well, Mrs. Chapman, how are we going to solve it then? Well, let's create a table. Remember, a table has your x and y coordinates. I'm going to make it look like a percentage sign. When I plug in 0 for x, that's going to give me y. When I plug in 0 for y, that's going to give me the ordered pair for x. I can graph 2 points, and that will be my line. That's a lot easier than plugging in 5 numbers, isn't it? Just find find x and y coordinates. Or, in other words, where's it cross the y-axis and where's it cross the x-axis? Okay, so step 1, or step A. 3 times 0 minus 5y equals 10. The key here is notice when I plug in 0 in for x, y is my only variable, so that's what I'm going to solve for. 3 times 0 is 0, I'm not going to write it. Minus 5y equals 10. Solving for y, so I'm going to divide by negative 5. That equals 1, so I make a 1. Oh, look, that looks like it crosses it out. Y equals negative 5 into, or 10 divided by negative 5 is negative 2. Okay. Now I'm going to do the opposite and plug in 0 in for y. Notice the 0 is under the y. So I have, where should I do it? Do it right here. B. 3x minus 5 times 0 equals 10. Notice when I plug in the 0 in for y, my only variable in the problem is x, and I can therefore solve for x. So I have 3x, negative 5 times 0 is 0. I'm not going to write it. I'm left with equals 10. Divide by 3. And therefore x equals, that leaves us with x equals 10 thirds. 10 thirds, divide, 3 goes into 10 3 times, 9, 1 left over, do my check, 3 and 1/3, 1/3, so I have 3 and 1/3 right there. Okay, so those are my coordinates. Now I need to graph them. My first graph, my ordered pair, is 0, negative 2. Is my y positive, y negative, x negative, and x. There we go. X positive. We always start at the origin. Our first ordered pair is 0, negative 2. So I'm going to start at 0. Not going to go anywhere on the x because it's at 0. And then it tells me my y coordinate is negative 2, so I'm going to go down 2. That would be 0, negative 2. Now I look at my next one. I have 3 1/3 and 0. Remember, that's your x, that's your y. I'm going to go to the positive 3, 1, 2, 3, and about 1/3 way. And y is 0, so I'm not going to move. So this is 3 1/3, 0. And then I'm going to connect the two lines. And I'm going to draw the line. I always tell my students, draw it right through the whole entire graph. And draw, there you go. Okay. Now remember, I want to make a key point. Here's your domain. Here's your range. Okay. Something very, very, very important. If you notice on your x-axis, it's going to, if I go up and down, this is a line that goes on forever. It's going to go on forever and ever. And your range will also, your range and your domain is all real numbers, because this does extend forever and ever, infinite, and it eventually will cross all your range numbers, which is on your y-axis, and it will eventually cross all your x. That's a little difficult to understand, but I just want to kind of throw it in there. Let's take a look at this example. Y equals 8x minus 4. Is it linear? Well, I have a y, I have an x, and I have a number with no variable. Yes, it is linear. Can I put it in standard form? Sure can. Let's say y equals 8x minus 4. Remember, standard form is ax plus by equals c. I need my x to move over to the other side, so the opposite of positive 8x is a negative 8x. So I'm left with negative 8x, a positive y. This zeroes out, giving me a negative 4. Okay, remember your a or your coefficient in front of the x cannot be negative. So I'm going to multiply everything by a negative 1, giving me a positive 8x, a negative y, and a positive 4. You don't really have to write that positive there. Okay, it is linear. Now, before I do anything, I need to determine whether or not, what are my x intercepts and my y. That should be one line. Intercepts. Okay, in order to do this, I can take either equation. I can take this one in standard form, or I can take this one. Either way, you're going to get the same answer. Before I show you how to solve for an x and y intercept, what we're looking for on an x-intercept is where it crosses the x-axis. Okay, so it's going to cross somewhere along the x-axis. We need to know the exact point. And the y-intercept tells me where it crosses the y-axis. So you'll always have those 2 points, where it crosses the y, oops, I want to go straight, where it crosses the y and where it crosses the x. Okay, let me show you how to do that. Now, this x, to understand the x and y intercept, this x is when y equals 0. Okay? So, your x-intercept, you have an ordered pair, and when looking for the x-intercept, your y will be 0. Your x will tell you where it crosses the x-axis. And for the y-intercept, it's also the opposite. You have the ordered pair xy. Your y-intercept will be when x is 0. Once again, looking for y. And so basically what we're going to do is we're going to plug in these numbers, because what a lot of people don't understand is that your ordered pairs in any of your equations is your y and your x. Those are your ordered pairs. We just don't know them when looking at the equation. So if I want to know what the x-intercept of this equation is, I have y equals 8x minus 4. I want to know, what is the x-intercept? Well, if I look here, it's the opposite. I'm going to plug in a 0. The coordinate for your y is 0. Equals 8x minus 4. Now we need to solve the equation to find out what x is. So I need to get x all alone, all by itself. And when doing that, I need to move the negative 4 over here. The opposite of negative 4 is a positive 4, giving me 4 equals 8x. I need to separate the 8 and the x. They're connected through multiplication. The opposite of multiplication is division. So if I divide there, I'm going to divide here. That equals 1. And I'm going to reduce 4/8. 4/8 divided by 2. 4 divided by 2 is 2. I'm going to divide by 4. It's a bigger number. Where's my eraser? I always use the largest number to divide by. That way it'll give me the smallest result. Okay, 4 divided by 4 is 1, and 8 divided by 4 is 2. So, 1/2 equals x. That is my x coordinate. So when y is 0, x is 1/2. Now that I have a point, I can graph it. Your x is 1/2, so I'm going to go over about 1/2. And your y is 0, so I don't go up and down. That's my x-intercept. Now let's find the y-intercept. If I look here, I look for my y-intercept when x is 0. Y equals 8x minus 4. What did I say? Oh, the opposite. Since I'm looking for my y-intercept, I'm going to plug in 0 in for x. So y equals 8 times 0 minus 4. And you can do this with either equation, your standard form or your y-intercept form. Y-intercept form means it puts it says y equals. Okay, so I'm going to solve. 8 times 0 is 0. Y equals 0 minus 4. And 0 minus 4 is negative 4. So, what that tells me, that's my x, that's my y. What that tells me is when x is 0, y is negative 4. So I go to my y-axis. I always start at the origin, 0, 0, and it's negative 4. So I'm going to go down 1, 2, 3, 4. And I have my 2 points. A lot of teachers like to find 3 points. I'm good with 2 points. I'm going to draw this as straight as I can. See, that's not very straight. It is, I'll tell you what, it's difficult to draw straight on this tablet. And I can go ahead and put an arrow on the end. And this is going to go all the way up like that. Okay? And there's your line. Now you know your x-intercept, and now you know your y-intercept. Okay, here we have a word problem. A telephone company charges $4.95 per month for long-distance calls, plus 5 cents per minute. Yes, back in the day, we used to have to pay for long-distance calls, believe it or not. I still use this equation because it's an excellent way to represent how to graph real-life data. We're going to let the equation 5 cents per minute, or 0.05 m, plus 495, where m is the minute it's called. Now let me explain something to you quickly. This here is your rate or your slope, okay? The reason being is because technically it's 5 cents per minute, and we're using M to represent the M. When dealing with equations, and you're only charged $4.95 once. So in this case, I'm going to go ahead, instead of finding my x-intercept and my y-intercept like I previously was, I'm going to go ahead. I need a couple points. I'm going to check and see how many minutes I would talk if it would change it. So if I talked 1 minute, what would the cost of my monthly phone bill be? If I were to talk 5 minutes, what would be the cost? And I'm going to plug these numbers in for n. So if I had C equals 0.05, that's how we represent 5 cents, times 1 plus $4.95, C would equal 5 cents times 1 is 5 cents. And if I add 5 cents to $4.95, I'm going to end up with $5. So the cost of my phone monthly bill would be $5. Well, what if I talked for 5 minutes? Then I would have C equals 0.05 times 5 plus $4.95. And 5 cents times 5 would give me 25 cents plus the $4.95. And $4.95 plus 25 cents would be $5.20. Okay, now I'm going to go ahead and graph these two. How do I graph? Well, let's go ahead and take a look at what we're graphing. What are we looking for? We have minutes, and we have C as our total cost. Notice this is my X value, and this is my Y value. Reason being, every time I change my minutes, my cost is going to change. So the cost depends on the minutes. So on the y-axis, we're going to put cost, and on the x-axis, we're going to put minutes. And one thing to note, when doing graphing, time always goes on the x-axis. Just a little hint, just a little something to know. Okay, so this is my first point. Where is it? It's 1, 5. Okay, I'm going to go over 1 and up 1, 2, 3, 4, 5. My next one is 5 and 5/20. So I'm going to go over 1, 2, 3, 4, 5, because I talked for 5 minutes, and I'm going to go up 5 and a little bit more for 5/20. Oh, didn't want that. Where is it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And a little bit more. Okay. Here I have 2 points. And as you can see, my line's not that very straight, but you get the point. Here's your y-intercept, which notice it's also right here, y-intercept. And here is your x-intercept. Also notice it is increasing, so as the more minutes we talk on the phone, the more we're going to have to pay. Okay, very good.